we are going to record this and I'm going to put it on YouTube so you have access to it. This is not to replace your participation class, as you know, all right? It's only to help you. Of course, there are a couple of cases where you will not be able to come. Knock on wood, let's assume you get COVID. All right, so we'll talk about that too. If you isolate yourself for that, of course, that's going to be an option, so you don't miss lectures because it's synchronous, it's in real time, all right? You can also do it in an asynchronous way, which means that you were in one of the lectures, but you want to revisit some of the things we discussed in class so you can really go over. So those will be in YouTube, and then you will find them like after today. I will go and put under week 1, under this one here that says January 19 to January 23rd. In fact, includes Sundays, obviously. So under that, I will put the connection to the YouTube. So you will be able to get it from here. So you don't have to go through MediaSite. All right, so how are we going to run the class? There are 2 sections. The 2 sections will have the same types of lectures. Now, they're not going to be identical because, as you know, in every lecture, I will be writing things. I will come prepared with material that I need to cover in class. And I will use my iPad. I will use Notability to be able to see me writing in real time. All right, I'm not going to use the board. It's very difficult to see from there. You're going to be able to see what I'm doing on iPad. And then I'm going to make a PDF file of this and upload it. So the lectures will have the same kind of material, but they will not be identical. Sometimes we solve one problem in one case, another problem in the other, depending on what students want or what kind of questions they are asking. And so my advice will be, check it to see whether there is anything different. We go into problem solving sessions, and I will talk about those. I will put the problems, if they are different, from each of the sections. So you will see more problems available. So you will have that. Homework is going to be the same. And homework is going to be distributed, regular homework, every Sunday at 7 p.m. And is going to do next Sunday at 6 p.m. So by 6 p.m. on every Sunday, you need to remember you're going to have to submit your previous homework, and then there is going to be an hour later, there is going to be a new homework. There is no penalty for late homework, because if I put the solutions up immediately, then I cannot accept your homework. All right. Now, if there are situations, and there are some, when something is happening, and sometimes if it's due to another class, there will be a number of you who have the same problem. And if you come and say, you know, we have this conflict, we cannot submit it, I will then, I'm not going to announce it to the rest of the class, but I'm going to delay placing the solutions up until you return your homework at the time that we have agreed upon. All right. So let me know. If there is a valid reason, let me know, I will accommodate. Let's start talking more about the syllabus. Everything, I used to have everything on this page. And what I will try to do is to not make it impossible and to overload it with information so you cannot find anything. I will try to make it clean. And maybe you have 2 clicks to find all of the information you need. So for example, let's start with the syllabus that we'll do today. It's only 1 click for that. And the information is consistent. I add also, it's 3:41, I'm sorry. I was thinking up until the last minute, there was 3:40. And then I realized there was another faculty ready to teach. Then I remembered, because it's 3:40 in the morning, that our class for the afternoon is 3:41. So I will have to make that change and clarify it. So 3:40 in the morning, 3:41 in the afternoon. So this is information about me. If you want, I got my degree in Greece long time ago. I graduated, in fact, I graduated in 77, if you don't know. It was so long time ago that we're only 2 women in a class of about 250 students. There are more since then, but that's how it was. Since then, I went to graduate school at UCLA, got my master's and PhD in 1984, finished with my PhD, and then I became a faculty member at Michigan, University of Michigan, as an assistant professor. And since then, I have been teaching. This is my 5th institution. So I have moved around quite a bit. And I have enjoyed that because every university has a different group of faculty, a different group of students. You learn all the time. If you stay in one university, I stayed at the University of Michigan for 18 years, and I have to tell you, at the end, you just get burnt out a little bit. Same classes, same people, same research, same office, you know, and with all of the kind of work that faculty do, I really was ready to crash. So moved from there. But I have been here for 3 years, and I really, 2.5 rather, and I really enjoy the university. It's a great institution. So you are students in a great university. And I have been in many, so believe me when I say that, it's true. I have never missed a class in my whole career because I was sick. I don't get sick very easily. So I hope this is gonna remain the case for this semester. So you're not gonna see me missing a class, but I will accommodate your needs. So my experience, so you can see also that I'm doing research in electronic circuits. I started doing research in the Naval Research Lab on radars, and that was in the late 70s. And then I went from there to integrated circuits in the early 80s, when all of the work in monolithic integration and everything was done, and all of the work for this was done there. So you see how many years it takes of basic research for something to really come up on this. This one is so small because it has 3-dimensional integration, and all of the work on that was done in the 80s and the 90s. Since then, however, my work morphed accordingly. I don't do packaging and integration anymore. Things have really happened. Now they are in commercial form. But my work right now is on intelligent circuits, circuits that have the capability to become intelligent. And I will speak about that because a lot of the things we'll learn in this class have applicability to all of those things plus more. So here, for example, if I were to go to the learning goals, our goals will be to learn the fundamentals of electromagnetics. So you guys can apply, and girls, you can apply to everything that spans this almost 80% of electrical engineering. In addition to that, I have not included here is bio related, all right? So a lot of things, so imaging, for example, MRIs is an area that is so much specific to magnetic fields, all right? Now, we don't have time to learn the fundamentals and then from there go and talk about all of these areas. However, what I plan to do for the blue areas, which are primarily the areas I have been working on, I plan to always talk to you about applications. So this, since wireless communications primarily today, including 5G and 6G, has been the center of my work. And from the hardware point of view, I'm doing coding for modeling, but I am not a network person. I'm not doing communications, all right? I'm developing hardware, meaning the receivers that you have here, the receiver is the hardware, all right? So this is what my work is on. But we are gonna talk about how you are going to take, for a circuit designer, how you can take the fundamentals we are going to learn in this class and apply them into an engineering project, which is to learn how fields behave and then use this information to do very high performing circuits for communication purposes. All right, so that we are going to go to some detail and I will give you examples. For the other areas, I'm not going to do that. However, you can take get a feeling of how fundamental electromagnetics is and how you can apply it to all of these areas. Without understanding electric and magnetic fields, it's very hard for you to do a good design as an engineer in any of these other fields. So I know that you come to electromagnetics with a lot of skepticism because everybody thinks, oh, it's very difficult on math, right? So it has that kind of reputation. That's a stereotype. Talking about stereotype nowadays, we have stereotype electromagnetics because yes, there is math in everything. There is math in everything. The question is, how do you use math to understand science? So math is like a language, all right? It's a language that we develop. Science exists, is nature, all right? Science is a description of all of the laws that govern this universe, all right? From the largest scale of planets and galaxies and systems to the smallest scale of a nucleus. So these are the phenomena that govern us within our body and in megascales. Now, in order for us to understand these phenomena, not qualitatively, but to be able to use them, we had to develop a language that connects the phenomenon with some tools, like, you know, software is a tool, MATLAB is a tool. Mathematics is a tool, is a language we use to understand science. So the mistake a lot of times that it happens in classes like this is that we get stuck with math and then we miss the ability to understand beyond that. It's like somebody comes to you and says, this is a beautiful novel. Let's assume that before I came to the US, when I was younger and I was speaking English, but I was limited in my vocabulary. So somebody will come and say, this is a beautiful novel in English, all right? So could you read it? I have to tell you, by the time I would use the dictionary to go through all of the words that I did not know, and then struggle to make meaning out of the sentences, I'm not even sure I will know what the novel said. I will only remember the horrible time I had to be able to take that novel and make sense out of it with my limited capability, all right? So the same thing applies to electromagnetics. If we focus on how to do all of this math in there, which is wonderful if we could, and you're not gonna achieve this in this class, I'd rather prefer to help you focus on the physics. So you leave this class and say, I know what is happening in X case. I know what is happening. Somebody comes to you, you know, it's a circuit designer, say, in a digital circuit designer, and then there are design rules. So design rule, why rules are important? Because somebody's gonna ask you to go and design a circuit, and they will tell you, use the rules X, Y, and Z, and they are inside their software that designs those, all right? There are design rules. The design rules say, for example, that two lines, connecting lines, cannot be brought closer to something. Who said that? That cannot be brought closer to something. The theories we're gonna learn from this class is what helps you understand how close you can bring them. Because of proximity you have, and because of the waves, every time you have a current that flows, all right, whether it's digital bits, because yes, digital means zeros and ones, but practically you have high frequencies in there. So when you have an electromagnetic wave or an electric or an electrostatic wave, and then you're in close proximity, things happen. So it's that theory that helps you understand you cannot bring two lines closer than something, right? So that's how I want you to understand the science. Now, math, we are not gonna spend all of our time doing integrals in closed form. The book has derivations. When we come to a case like this, an example, I will ask you to read the book, but I will ask you to calculate your integral after we bring it into some reasonable form, all right, to calculate it using MATLAB or using Python, whatever language you want. And then we are going to focus on what we observe from the physics point of view. All right, so we're not going to get stuck. Now, I would love for you to not feel horribly bad about math, because math is something that you're going to see in front of you every time. So, but we're not going to get stuck because of math. All right, so that's, you need to remember. And the other thing about this class, you will see that in this class we have individual assignments and team assignments. So in fact, this is a class schedule by week if you want to see it, but I will go down the grading philosophy, and this is where we are going to talk a little bit about the specifics in this class, but I will then stop for a moment, and before I get into this, see if you have any particular questions. Okay, I don't think you have any so far. All right, so number one question that I have, I'm asking on your behalf. Why do we get points in this class? Why do we have all of these things to do, which seems overwhelming? And how are you going to get out from points to grades? All right, are those valid questions? Okay. All right, let me start with why so many. As you see here, you have exercises that we'll do in TapHat. TapHat, and I will come to this, is an online tool that I can give you a multiple choice question in the class, and you can respond to it whether you are on Zoom. It's not a clicker. If you are on Zoom, you can do it from home at the same time with everybody else. It can be done synchronously from here or from like 10,000 miles if you want to be so far away. That's the good thing about that app, as opposed to clickers where you have to be present in person. So, but I can ask you a question. I can give you say 5 minutes, and I can say, just do it's gonna ask you X, Y, and Z, which is correct, A, B, or C, and you will have to check, and automatically it grades it. Now, if it says here that we may have 25, all right, that was mine for every single lecture, like the Mondays and Wednesdays, for example, we can have a short exercise. It's going to be 30 points, 15 points for doing it, and 15 points additionally if you do it correctly. So the idea, the same thing applies to the quiz, which is on Fridays. Why I call it quiz? Because it's like an effort to bring some concepts together that we have seen over the week. 30 points for just doing it, and an additional 30 points for just doing it correctly. Now, why do we have the exercises? Which sometimes the exercise in the class, it took us a long time to cover one concept. And I may give you the exercise, and I may give you extra time to do it in the evening, for example. Same thing with the quiz. Why is it that these are important? Why then do we have this, and then we have individual homework, individual midterm, individual final? Let's talk about that. And then you have the team ones. We don't know because none of this is going to be a lot. For example, the individual homework could be one problem, and another problem could be in the team homework. All right, so they seem to be different, many, but each one of them is not going to increase. So the whole work here is no more than you normally do in a class of 3 credits. It's just that it's divided in pieces like this. Why do I do all of these things? Because of how the brain learns. And maybe some of you have been connected with some bio topics, and then you know a little more about how the brain learns. But what we know now about the brain is that the brain learns with very with repetition that happens in small intervals. And why is that? So, for example, my understanding of of electromagnetics is in my long memory. All right, that's where my brain stores all of this information. But now that I'm speaking with you, my brain works in what we call the working memory. So what is the working memory? The working memory is information that the brain gets from the long-term memory, plus whatever other information I see now from the class. I see your faces. If I see somebody raising his or her hand, that's new information, all right? It all goes into the working memory. And my discussion today in this class, everything that I do right now is coming out of the working memory. So if I leave, all right, so somebody, what's your name? Cody, yeah. If Cody asks me a question, all right, or gives me a piece of information, and then I forget, and then I don't do anything with that. So I leave this room, I go to my office, see my graduate students, and I do another meeting, and then go home, and then I prepare for another meeting tomorrow, and all of this. I may totally forget it. I may come here on Friday and say, could you please tell me what you told me? Could you remind me? That's what I would say. And why is that? Because the working memory does whatever I need to do right now to have this discussion with you. And then only particular things that I will remember after I leave this room and go to my office and say, oh, you told me that, I need to write it down. Or I need to make this correction about the room, for example, 3421. If I don't do it, when I go to my office, then it is very possible I will forget it and you will have to remind me. And it is possible I forgot, not is possible. The truth is that I forgot because it never went to my long-term memory. And what happens if you learn something and then you forget about this? It never gets registered. So you will always have to go back and be in the learning effort, all right? Like spend another hour to remember this lecture or go through the video. If you leave this class and then wait until, for example, Monday to remember what I said about the syllabus, you may have to go back to this video to see what I said or read the whole syllabus again. However, if you were to think about it, even for 5 minutes, and it's not the syllabus, it could be another topic, all right? Even if you spend 5 minutes to recall a piece of information that you got through the week and not wait for another 5 days, then the way the brain works with multiple spikes, because the spiking every time we remember something, then it stores this information in the long-term memory. Okay, how does this translate in an advice I'm going to give to you? Because I've seen that. In fact, I've tested it every semester, and I look, because you know what Canvas can show me how much effort you guys put. And there are people who put effort constantly, all right? And there are people who put these huge spikes before a midterm. I don't know how many hours that these people spend, and they're not doing any better. In fact, they do worse from another student who spend this low-level effort throughout. So if you take 2 students, and one student spends 15 minutes every day to even remember the topics, and the other student waits for 1 week or 2 weeks to go back to the topics, guess who will have to do a lot more work to have the same kind of outcome? The student who has not spent this little time that is required every day. So you learn better if you sustain your thoughts about the topic, even at a low level, than if you were to kill yourself before a meeting or the last moment before the last day before the homework to do what you need to do. So just even to conserve time and improve your outcome, I'm trying to give you enough small level work throughout the week so you stay connected with the topic. That's why it's all of this. Now, it is a lot, and that's why you need to have the capacity to manage it, all right? So, it means, and I'm trying to help you with that. You will need to make sure that you guys do the exercises or the quizzes, the individual homework we can apply. And then the teamwork. And I have already split you into teams of 3. And in a few weeks, when we see how many will stay in class, how many others may have conflicts, then when I believe we will finalize the teams, but we're not going to do major rearrangements. So if a team, for example, of 3 loses 2 members, then this one person will have to be added to another team, all right? So teamwork, team homework is you're gonna get the team homework at the same time with the individual. What is the difference between the two? Individual homework implies that I would like you to work on the homework by yourselves. You can ask me or a colleague a general question, but you cannot ask me or a colleague to give you the solutions, all right? If you come to office hours, I can help you, but do not ask me to solve the problem for you. What means the following: when you try to solve a problem and you get stuck, all right, there is always a reason you get stuck. There is, you come to a point where you cannot make a decision of how to move forward. At that point, I can help you. I can help, if you come, say, to a fork, I can help you make a decision of which direction to go. But I cannot take you to the end point, all right? So the end point, which is the final solution, is going to be your responsibility. That's what happens in the individual efforts. In the team efforts, that's not true. In the team efforts, I want you to work with your team and try to, like you do projects, all right, to develop one solution for the team. Now, what happens, what I have seen happening, usually that works very well for the majority, like for 85%, if not more, of the cases. However, there are a few teams that had a couple of problems. Not many, but I will tell you what the problems are. One is only one case that happened where there were members of the team who would not agree to a common solution. And then they insisted on submitting their own. I don't want that. I want you to work towards a common solution. If you cannot come to a decision, that means you're not ready to work as an engineer. Engineers do not work by themselves. I have to tell you, if you go and work, they're not going to give you one project and say, go to this room and solve it. They're going to tell you, go and work with a team. And if the team does not do well, you're doomed. It does not matter. If your project does not go anywhere, then your manager does not care of who did not work in the team. It does not care that you could not decide what the solution was. So we have to learn that, all right? Engineering is a team sport. It's not an individual sport, all right? You don't go, you will never see yourself doing something on your own. So that's what I want you teams to make sure that you agree. If you have disagreements about an approach, then come to me, because obviously there is something you are missing at that point, and I will clarify that to help you come together and get the solution. The other thing, there are some people who just disappear. Okay, MIAs. And then nobody sees them. All right, if that happens to your team and you feel like out of 3, one person is not showing up, then you need to tell me, because eventually the idea is that every member of the team is going to get the same grade, because you're going to submit one solution. Everybody's going to get the same grade for that, the same points rather. There's no grade, the same points. But if one person has not participated, I need to know, because I can remove the points from this person. And I will let this person know why I'm removing the points. All right? Because it's not fair for anybody to let everybody else do the work and get just the credit for it. So this is how this is going to work. Now, why am I developing points? Okay, So my philosophy for a class is that my goal as a faculty member, my number one goal is to help you learn about the topic. Grading is only an assessment that I have to provide at the end. A grading is not my goal. That's not what I need. I don't want to optimize the grades I give. I don't want to have a bell curve. I don't care about that. If you all get at the top bound, so these are all hypothetical, right? Assuming that all of this happens, then the highest possible number of points you can get for this class is 5,725. Usually it does not ever get like that. We're going to miss something in one day. We're not going to have enough time for an exercise. You know what it is. So usually it's going to be a little lower than this. But that is going to become the actual number, the actual highest number of points will really set the top, all right, of the band. And then I will tell you as we go to that on how usually that's the, I would like to have a broad range. Okay, if everybody in this class, say in under this scenario, goes above 4,500, I don't care giving two A's to everyone. So you don't compete with each other. I'm not saying that I will give 30% A's, 30% B's or whatever, 50% B's and 20% everything else. No, I'm not gonna do that. If you all learn in a way that satisfies the requirements for this class, you will all get A's. What I'm not doing is, if I see that the total number of points is very low for a class like this, you know, 2 or 3 people, all right? That implies that I failed in some ways. Maybe I gave you things that were too hard for what we cover in class. I'm not gonna penalize you for this, all right? That's why I always take the maximum number that has been achieved in a class and then set that as the top in terms of points. And then from there, I get the grades. And we'll discuss it as time goes. I'll show you also along the way some distributions. So the other thing that you have also to pay attention to, and then I will also stop for any questions, is the incomplete grade. Any of these categories, if you miss 50% in any of these categories, then I will give you an incomplete. That's the deal. For example, if I give you 12 homeworks and you miss 6 of them, get an incomplete. If you do not show up for a midterm, it does not matter whether you have the points. If you do not show up with a midterm, because the midterm, you know, you can say, well, I did all of my, let me tell you, you will try. I had a student like that who, he was doing these calculations. He forgot to read the incomplete at the end. So he said, well, I got very high marks in homework. Look how small is the midterm. I can afford to miss it. No. The answer is no. Because then I'll give you an incomplete and it's all there from the beginning, you know it. Okay. Now, there may be reasons to miss things, but we'll come into an agreement how we're going to solve that. All right. You know, don't surprise me, because if somebody comes, I had a student who missed 50% of the homework. And he said, well, I missed it, but I'm not going to fail the class. I have enough points. I said, no. So you know what I did with the student, which, you know, it's very difficult for me and the student. I said, unless you do this extra, I gave the person 6 extra homeworks to do. And because he was working during the summer, it took him up until October to get a degree, to get a grade. And in this class, if you get an incomplete, you cannot continue. So be careful. All right. Now, I'm not gonna, I will try to be, you know, I don't like penalties because nobody learns via penalty. Nobody. The brain does not learn. The brain creates a fear if you are penalized on something, but does not learn. You may remember that you got afraid, but you're not going to remember why you got afraid. I mean, the kids are like that, all right? They remember if you know, somebody beats them up for something, another kid, They may remember that they got that, but they may not remember what the argument was. That's how it is, all right? I don't want you to fear the class. I want you to feel free to learn, to think that your work is going to be taken into consideration, and to let me know if you have any problems. But at the same time, you know, there are some rules. We cannot run the class without rules, because then it will become chaotic, all right? And it's gonna be unfair for everybody else. Okay, with that, I would like to pause and then see if you have any questions. Yes?
How is the bonus points?
Thank you. You know, like talking about working memory, I thought about the bonus point while I was speaking, and then I forgot about it. So, bonus. Here is how I do it. All right, so as we make progress in class, I'm gonna upgrade your grades. So the top cut points will come automatically. I have to upload them. I will upgrade those, but you will have access to your top cut points anytime from your accounts, all right? But I will have to upgrade to place them on Canvas, so you have the total. I will do that like 4 times or 5 times throughout the class. When I make those upgrades, I will also add, I will look, for example, I moved it too much. Okay, let's go to the individual, and then, in fact, I need, it's all 75, not 65. I will correct that. So here, when I do this, I'm looking this 5 times throughout the semester, and I look at, I try to upload all of the points and look where you are. Then I will look for those who at that point in time have achieved 75% of what the maximum would be up to that point. I will give you 15 extra points. That is for exercises, 30 points for a quiz, and 50 points for homework separately, all right? You may be 75% here, but you may be 70% here, all right? So you are going to get 15 points for that. Also, I will check those who are at 85%. Those who are at 85%, they will get 75, because of course, if you go to 85, you have to go through 75, all right? And then they will get also the additional. For those who are at 95%, then you get 75, 85, and 95. Do you know why I'm doing that? I'm doing this to be able to create some separation between the points. I don't want people to be within 1 point with each other. All right, it does not change anything, but those who have done very well, it gives them more space to move up. But in any case, it's also a good thing because it gives you some markers. All right, you know that if you go above this, you're going to get 30 extra points or 60 extra points. So that, for example, can be 105 points. That's a big thing. So I will do this during those 5 times, and I will do it also. Then I will go back and check the final points when everything has now been done before I submit the grades. Then I will do and look now. Again, have you been, at what level are you for each one of these, your points, your total points? If you are at 85% level, you're going to get this too, because you're obviously above 75. If you are at 95, you're going to get this 3. If you are at 75, you're going to get that. But I will do it at the end. Yes.
And is that based off of completion or the actual grades that you got on the assignments?
The actual grades that, I mean, you mean, what do you mean completion?
Well, it says like 75% achievement. So that's if you have over a 75 like grade on average for those assignments. That
Yes. Yeah.
All right, thank you.
I mean points, yeah, over 75 points for each one of them. If you are in a team, then every member of the team will get the same. Yes. Could you speak up a little bit?
Yeah. So for the team assignments, agree on
Yes, the meter and the team meter, thank you for asking me. The team midterm and team final are take-home exams. You will solve them as a team. And I will give them to you before the individual midterm and the individual final, because the teamwork is going to help you also review some things. So not only you do a review, I'll give you points for the review. See what I'm saying? So you're going to get it ahead of time as a take-home, and then we're going to have the individual where you're going to work separately. I'm giving you points for everything. Any other questions? Okay. Yes.
For registering for the class of compound, I find that
There is a need. There is in the syllabus. Wait, there was a good question, please. For Top Hat on the syllabus, there is a link. Go to that link, and then it's going to take you. You have to enter TAMU and then the class, and it's going to take you and to register you for this class. If you have a problem, let me know. But you register for that, and I will give you an example on Friday. Yes.
so we can pay for the top hat.
Yes, I'm afraid.
And then one thing, did you make the groups, but have you put them anywhere?
Yes, no, you can find the groups are made. You can find the groups if you go under people and groups, and you will see your team. All right. Okay, any other questions, you can email me, but I will see you on Friday. Thank you.
I guess it didn't have to make
For the class,
yes.
for my class, for this class. Can you show me? Yeah. Yes. It's on the syllabus. Okay, one more thing, because I forgot. There is an individual assignment on the syllabus. I'm asking you questions about the syllabus to make sure that you read it. And it's due on Sunday. But it's all questions about the syllabus, all right? Thank you for telling me.